In this video, I want to demonstrate a calculator experiment for determining when a limit exists. Uh, it will also be a demo of how to use the list feature of the TI-83 calculator. All right, let's look at two limits, examples here. Uh, First, let's look at the limit as x approaches 2 of the absolute value of x minus 2 over x minus 2. And then we'll look at the limit of x squared minus 4 over x minus 2. So both of these functions, if you plug in x equal to 2, uh, are going to be undefined. They give you something like 0 over 0. So how do we evaluate whether or not a limit exists in these cases? Well, let's look at a number line here. If I take a sort of a number line, that's a pretty good number line, and supposing I want to look at the point 2 on here, so here's the point 2. Now, how do we determine whether or not this limit exists? Well, what we want to do is to start and look at points getting closer and closer to 2 from below, and then we want to look at points getting closer and closer to 2 from above, and we want to evaluate what does the function do on those 2 points. So how would we do this? Well, the standard way of doing this would be to develop some sort of list. So the first list, how do we get closer to 2 from below? Well, let's start with 1.9, and we go to 1.99, 1.999. Oh, how many times do you need to do this? All right, that should be enough. And then we'll look at the second list as we approach it from above. So in that list, we'll say 2.1, 2.01, 2.001. So you see we're getting closer and closer to the point 2 from above. Now, we'd like to calculate the values of the function, say the first one here on each of these. So what we do is create a third list, and we would calculate the function on the first list, and we would like to compare that with what happens if we then create another list where we calculate the function on the second list. Okay, let's go see if we can actually do this. I'll pull up a calculator here. Let's hopefully get all of it in here and turn it on. Okay, now we need to find the list functions here. So this is going to be under stat, and under stat there's the edit, so we can say list 1. And so, well, the list is nothing there, so we can just put in the values here. 1.9, and go down 1.99, down again, 1.999, down again, 1 point, and then 4 nines, I guess. Now let's go over to the second list. Oops, I better tell it to go down. Now let's go over to the second list, and we'll put in the values approaching 2 from above. 2.1, 2.01, 2.001, I could hit enter just as well, 2.0001, and well, that's it. Okay, now let's go over to the third list. Now the third list, remember, we wanted to calculate the value of the function on the first list. So how are we going to do this? Well, this is the absolute value, so we have to put in the function here. So what I want to do is to go up to the heading so that we will put in a function in the heading using as an argument the first list, and then it will calculate the values for all of the first list. Okay, so where do we find the absolute value function? Well, it's a math function, And if I look very carefully over here, there it is, under absolute value. Okay, and so this will be the absolute value of what? Well, it'll be x minus 2. So I can put in, well, the x will be the first list. And so how am I going to find the first list? Well, the first list is a variable down here, so it's the second one minus my function 2. Okay, close my parenthesis there. And then I'm going to divide that by what? The absolute value of x minus 2. Well, I'd better put parentheses around that so I don't mess things up. And so I want to put in the x value is again going to be replaced by the first list, which is the second one, minus 2. And I'll close the parenthesis on that. And that's my function, so I'll hit enter. And bingo, look at that. It gives every one of those values minus 1. Okay, which we could have actually seen if we had gone over here and computed the function here. Whoops, minus 1. So it would have been the value minus 1 along here. Okay, now let's go back and take a look at the second argument here. So now I would want to put in the same value. So I go up to the heading here, and now I want to put the values of the function in. So under math, go over 1, hit enter, and now I want to put in the second list. Well, the second list is second 2 and minus 2. Just repeat the same sort of thing, and then divide that by putting in parentheses the second list minus 2 again, and then I'll hit enter, and it calculates the value of that function on all of the elements of that second list. And now we see the value there is going to be plus 1. So as we can actually see, as we approach 2 from below, the values are minus 1. We approach 2 from above, we get plus 1. So of course no limit exists in that case. Now we can compare that with what happens for the second function over here. Well, let's see. We've already got in the list 2 and our list 1 and 2 gives us the values as we approach 2. So let's go over and just change the function up here in list 3. So let's how do we clear this out? Well, the way we clear it out, we go up to the list item, hit clear, and hit enter. That clears it all out. While we're at it, we might as well clear out the other one too. Let's hit clear, enter. Okay. All right. So now let's go up and put in the next function. Okay. So this is going to be x squared minus 4. Well, I better put in parentheses, and the x again, list 1 will be this case, second 1 squared minus 4, close parentheses, and I'm going to divide that by, and we put in the function again, list 1 minus 2, close parentheses, hit enter, and there it gives the values of the function, 3.9, 3.99, 3.999. It appears to be approaching a certain value, 4. Okay, so then what do we do with the next one? Well, we want to repeat and do the same thing. I just want to enter the function. When I put in the function and hit enter, it gives the values, and now notice we get the values 4.1, 4.01. So it is actually approaching 4 also. So in this case, both of the values are approaching the same thing. So in the first case, we had the function values going different. In the second case, if I draw a line over here, okay, in the second case here, the function values, as we approached 2, we're going to be approaching a value, and from above, it looks like they were both approaching value 4 here.